test statistic Z value. Okay, test statistic Z value is compared. Okay, test the Z value compared to critical star. Right? Here it is calculation. It is calculated, but this is from table, from normal distribution table. Okay, but either way is we will compare p-value to alpha directly. So for example, this one, our test statistic Z value is here. Critical Z star is here. Then we will say Z is bigger than Z star, so we will say we will reject H0. Okay, but p-value definition is p-value is when you calculate Z value, your minus Z is here, then the percentage, this percentage will have alpha, another half alpha, and p half value, half p-value. When you add all these two, the p-value, when you look at only this side, half p is smaller than half alpha, right? This is alpha, half alpha. This is half alpha because critical Z value is here. This area is half p-value. So when I use both sides, p-value compared to alpha, right? Z is bigger than Z star, p-value is less than. If Z is less than Z star, the inside, then what will happen? Then p-value greater than alpha, equal to like that. So comparison Z and Z star and comparison p-value to alpha, exactly same thing. Exactly the same thing. But why we do that? To compare the Z compared to Z star, we need to look at the normal distribution table to find out Z star. We need to look at the table. When alpha is different, we need to look at normal distribution table. But alpha is changing. If p-value is calculated directly, because Excel will calculate integration for us. So this area is calculated already for us. So instead of just star, if p-value is given, Z is calculated and relating p-value is calculated, then we don't need to look at the Z star. We don't need to look at the table. Just p-value directly compared to alpha. Alpha is given by researcher. Okay, that p-value is very small, 0.001. Is strong, extremely strong evidence. H0 is natural. It's quite different because here Z star minus Z star is this is alpha, half alpha. This is another half alpha. But our Z value is here. Then whereas p value is here, very, very small. Then it's quite different. Outside, Z value is much bigger than Z star. So there is extremely strong evidence. When you're going down, it is 10%, then it is some evidence that it is not true. So at 95% confidence, it will not be accepted. Okay. P-value is calculated. It's very easy. In the previous example, you need to read this one. So instead of this one, I'll use Excel file, my Excel file. The exactly same thing. So we already use this one. I have tested using Megastar. Then p-value is given directly. This is very important. Now p-value is given. So here alpha was alpha was 0.01. Then we don't need to look at the just this value. We don't need to. I will not use this one. Okay, I will not use this one. Instead, I will use this value. Alpha was 0.01 is bigger than. So what it means, then you need to look at the normal distribution table. Here is half alpha, 0.005. Another half alpha, 0.005. We calculate some jet value. This is relating jet star. This percentage, 0.1, jet, this is p-value, half p-value. So it means jet value is less than jet star, so inside of the acceptance area. This is acceptance area. P-value is bigger than alpha. It means Z is between less than jet star, between plus minus star. So it means H0 is accepted in this case. If it's outside, H0 will be rejected and so on. Okay. The first case was example on page 323. Sigma is known. 16 it was known. So we will use normal distribution table. Okay. Next one is sigma is known. Still normal distribution table will be used, but it's greater than. So it is the one-tailed problem. This is one-tailed problem. So you don't need to look at the table different. Your jet star is different. When you look at the table, you need to be careful to find out. Instead, I will use this p-value directly. This p-value is bigger than 0.01. Okay, so H0 accepted. So H0 accepted means less than 200, less than equal to, greater than 200. We cannot say it is greater than, it is less than equal to, no difference at all. Okay, so you need to be carefully find out one-tail, two-tail problem and correct entering. For this one, let's try to one-tail problem, how to do it. Let's try to run data, megastart, and click this one, and data summary input, where is, you need to select blank space up to here. And hypothesis number is 200. Is alternative is greater than. Then it just test because sigma is known. Alpha was 0.01 is 99%. Click OK. You see the p-value is calculated 0.610. Okay, 0.610. We already mentioned it. We calculate this one and then compare it to alpha, and then we can conclude directly. Okay. When you have a p-value is given, much easier for us. Okay. Next is now T statistics. In this case, when some population standard deviation is unknown, because we do not know sigma divided by the square root n x bar minus mu, we cannot calculate. This is unknown. So instead of this, we will use sample standard deviation S. In that case, we need to use T distribution, okay? Because it's continuous. We already explained this one. You look at the example. The Myrtle Beach International Airport provides cellular phone parking lot, cell phone parking lot where people can wait for a message to pick up arriving passengers. To decide if the cell phone lot has enough parking places, the manager of airport parking needs to know if the mean time in the lot is. The research question is this one. Mean time in the lot is more than, most important word is more. So it is, alternative is like that. Population average mu could be bigger than 15. Null hypothesis is no, it is not bigger, less than or equal to 15. He sampled only 12. N is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. Okay, when we will calculate X bar and S. Okay, and also it's inequality there, it is one-tailed problem. And sample size is 12, so degree of freedom n-1 is 11. Okay, and significance, let's assume significance 0.05, one tail is one tail, significance here 1.796. We will calculate T. This is T star, critical T value. This is, and we will calculate T value using this formula, 2.818. Then what will happen? Our test T is greater than T star, so it means outside. Inside is H0 is correct. Outside is rejection. This is, we will accept rejection is we will based on talk about null hypothesis. Null hypothesis is accepted here. Null hypothesis is rejected. So this is true. So H0 will be rejected. Okay, you can calculate in this way. Or when we calculate p-value, I will use, let's say, (1.796). Then this will be percentage was 0.05. 0.05. This is alpha. This is jet star. Okay. Test 2.8 is here. 2.818. So this small percentage, this is p-value of one-tail problem. P-value, if we know p-value, we don't need to calculate jet star. T star, sorry, this T star. This is T. Okay. So in this case, we will use p-value directly, and p-value is in this case smaller than alpha, smaller than, because it is outside. Okay. So I will look at the example here. So this 12, so page 330 is a hypothesis testing for population mean when population standard deviation sigma is unknown. The sample is 12 samples. Hypothesis testing 15 minutes, less than or 15 minutes, or greater than 15 minutes, and sigma is unknown. Alpha is 0.05. 1 minus of the 95% is one-tail problem. So we calculate sample mean, the average of this one. Sample standard deviation I have calculated. So I want to test this one. If you use this table, you need to calculate manual T value. Critical T value is 12 and the degree of freedom 11. 11 going to here. 0.05. So this 1.796. You need to read this number from the t-distribution table and compare these two. T statistic is greater than T star, so we will say H0 will be rejected. Okay, it's totally different. So actually, our sample average was 23. 23 is much bigger than 15. Do not use the just, if you compare 23 compared 15, is difference 8. So, okay, so H0 reject. If you conclude like that, you're totally wrong answer. You need to calculate T statistics compared to T star. I will use Megastat. Megastat result is I already calculated, so I will show you. And I will erase some of them. And data, Megastat, this one is not summary data. Real data is given. So here you need to choose data input and select data up to here. Hypothesized mean is, where is it? 15. Alternative H1 is greater than, so you need to choose greater than. Sigma is unknown, so you need to choose T value, T test. Click OK. Then Megastat calculate this value and copy and paste to here. So here we calculate your T statistics. Here, 2.817. We calculated, but test the study T value calculated, same thing. At the same time, P value is calculated automatically. Excel calculate integration. This alpha is, our alpha is 0.05 is greater than, sorry, 0, it is smaller than, okay, smaller than. So H0 is rejected. Using P value is much easier, much important to do that. Now I'll move back to this one. I have calculated. The last one, type 2 error. For example, type 2 error is type 1 type 2 error. I will explain this one. The previous one is I have explained the type 2 error is like that. Type 2 error is actually the person is positive, is contaminated by a coronavirus, but test said he is a negative. This type 2 error. I want to calculate this one. Something wrong, but our test cannot detect it. So this will be widely used in quality control. When we have a quality control, it says, you see, COVID-19 is negative, but test result is positive. Okay, this type 2 error is negative person you are contaminated. So type 2 error is, we will calculate this one, but you need to be carefully what is mu1. So and we will calculate, and then we will calculate beta and so on. I will show you the example. Western Wire products purchase steel bars to make a cutter pins. Past experience indicate that the mean tensile strength of all incoming shipment is 10,000 psi, is pound force per square inches. PS, pound per square inches. So it is strength. So this is not pound math, it's pound force per square inch, and the standard deviation is 400. So from is our historical data, it is good if our new incoming shipment is satisfied this condition is good quality. If not, it's some problem. So after we receive order the materials and parts are arrived, we will test it. Okay, such method is acceptance sampling, whether we will accept or not. To monitor the quality of the cotter pins, sample of 100 pins. So N is 100. And 100 samples are randomly selected and tested their strength. We measured X1, X2 up to X100 is we measured. In our hypothesis is same thing. It satisfy 10,000 psi. Psi is most important. So it's not, it's good quality. It's poor quality. Okay. The alpha is 0.05. The 5% significance level, 1 minus alpha is confidence level is 95%. Accept the shipment if the sample mean strength is between. So we calculate is 100 T. For example, we calculate Z value between Z star minus Z star, then H0 is accepted. Accepted means, okay, this shipment, this batch of arrival is 10,000, equal to 10,000. So we will accept total shipment. If Z is bigger than Z star or Z is less than minus Z star, H0 will be rejected. So we will not accept. We cannot accept the shipment. Okay, the critical Z star is plus minus like that, 9.922, 10.1078. So how to calculate? If the sample mean does not fall within the critical area, we conclude shipment does not meet the quality standard. Between that, it is quality is a standard. Quality is met, good quality. Okay, so it is in that case like that. But problem is poor quality. Poor quality is accepted. Poor quality accepted is better. We want to calculate how to calculate poor quality or better. Poor quality will be accepted. What is the probability to accept poor quality of shipment? Example is, let's say a sample mean X bar 9,900. Between this one is plus minus 1.96. So two-tail problem. Alpha was 0.05. Confidence level is 95%. Two-tail. So the star is 1.96. We know this number. Minus Z is minus 1.96. Okay? And we calculated that using Z is X minus mu divided by sigma divided root N. And then we recalculate this number is, we got this one. But one time is 9,900 is totally different. This value is much lower than this boundary. 9,900 smaller than 9,900. What is it? 9922. 9922. So it is actually, it is bad quality, poor quality product. If poor quality product, but this area is rejected, poor quality will be rejected. So this is a correct decision. But if our sample belongs here, poor quality will be accepted because it is between this range. So this is probability of error, type 2 error. So this problem, I have calculated this one. 334. This is another one. T-table. This one. Type 2 error calculate, page 337. Okay. So 100, standard deviation is 400, average 99. Okay. So we calculate test the statistics. You can use this one 9922. What is, so when you calculate the percentage, this one, we need to use, follow this probability. 9922, we need to calculate what is that value. 9922, what is here? Average 9900, T8 is 990, divided by sigma divided by square root n. And then we will calculate the percentage, okay? Then this area is how many percentage bigger. So it means when that value, we will calculate it 0.55. 0.55. We calculate this one. In this area, I will use insert, draw, and the yellow area 0.2088. So this one is 0.5. So we will calculate it like this. Equal to 0.5 minus 0.2088. 2912. You can, from table is, we can calculate like this. Or you, and then I just read this one from the table, and that value will be calculated. This from the table, this is just star. This is just star. This is just star is like that. No, sorry, this is, I made mistake. This is the probability, okay? This we will calculate it, the area of percentage. This is better directly. Okay, let's go to the, okay. I have explained this one. Type 2 error is a little bit, you may confuse that, but try to solve the homework problem, and you may figure it out. Question 7. Our textbook, page number 329. A recent national survey found that high school students watches average of how many movies per month. The average is 6.8. With the population standard, population standard deviation is, the sigma is 1.8. The distribution of a number of movies watched per month follows normal distribution table, and random sample n is 36. Reveals that the mean number of movie watches last month was 6.2. So X bar was 6.2. sample mean. The mean number of movies out of 35 students. But 6.8 is the national survey. This is the given numbers. So I have a question. My sample is 6.2, but national average 6.8. Is the same? Equal? Or it is equal or not equal? Okay. Or this is smaller than 6.8 and so on. You want to make sure when alpha is 0.05. But this, when it is smaller than, is one-tail problem. In this case, equal one is two-tail problem. You need to read what is question. Can we conclude that college student watches fewer? It's important word is fewer. So it is one-tail problem. Smaller. High school student 6.8. Okay, but I have sample 6.2 is college student. So this one is, I want to know mu is less than 6.8. Null hypothesis, no. The other side, less than, is greater than or equal to. Or some books says only just equal to 6.8. This is equal or greater than equal, is both are correct. But alternative, it should be less than. So one-tail problem when alpha is 0.05. The sigma is known, 1.8. So we will use jet test. Jet test will be used. The jet star. So it will be smaller than is. Then here is 68, maybe 62 is, it is z equals 0. This will be z. We need to calculate this minus something. This value will be minus something. So alpha is 95% is minus 1.645 at the 95% confidence level. So this one is how we will calculate is normal distribution table. Okay. 0.5. 0.5 means here this is 0.05. This will be 0.45. We need to find a 0.45. 0.45 is here. 1.6, 0.5. 1.645. Then the other side minus 1.645. Okay, so it will be minus, see, minus 1.645. When you calculate this one, it was minus 2. Then what is your conclusion? That is minus 1.645. This is jet star. Our calculate test is minus 2. Here, this is smaller than, so it's far from, it is in rejection area. H0 will be rejected. Or when we calculate minus 2, we need to look at p-value. P-value is calculated by the Excel program, but when Z is minus p-value, how to calculate? I will look at the table, Z equal 2, normal distribution table, where is it? Okay. Z value 2, 2.0. This percentage is 0.4772. The outside is 0.5. minus 0.4772. You 0.0228. The same thing. You minus 2. Okay, this area is 0.0228. That will be the p-value. Okay, I have calculated from the table. Our result conclusion is the mean value of DVDs watching is less than 6.8 per month because it is rejection. H0 is rejected. Okay. Question 13. The mean income per person in the United States is 60,000, meaning of 60,000. Distribution income follows normal distribution table. A random sample of 10 residents of Wilmington, Delaware, had a mean of 70,000. With a standard deviation 10,000, at the level of 0.05, significance level, is that enough evidence to conclude that? The question is, residents of Delaware, Wilmington has more income, so it is more. Then null hypothesis is less than or equal to 50,000. Is 70,000 is something is weird. The I think it is, there is some errors here. 13. So let me check the problem. This example is wrong. Okay, this answer is I will change the question. Okay, let's assume mean income per person in the United States is 50,000. Okay, Delaware, Wilmington is 60,000. Standard deviation is 10,000. Then we will calculate 60 minus 50 divided by sigma divided square root n. N is 10 samples. N sample 10 is 10 residents. Sample size. We calculate 3.16. Then t value will compare to t star. Okay. This t star is greater than, so it's very different. So we will reject this one. We will reject, yes. 60 is much bigger than 50,000. Okay. That's question 13. 19. Where is the 19? Oh, here. Washington, D.C. think tank announces the typical teenager sent 67 text messenger per day in 2017. So this is a typical one. To update this estimate, you form a sample of 12 teenagers and ask them how many text messages they sent the previous day. They said, like, some students, a lot. Very much. Another one is very, so division is very large. And alpha is 0.05. Can you conclude that the mean number is greater than, it's one-tail problem, then 67 is old estimate, historical number. With the internet is developed and more mobile phone is more popular, everybody has it. So we'll calculate p-value and calculate and so on. So greater than 67 is this one. The null hypothesis is not greater than, is less than equal to. When n is 12. 12 alpha is, and what else? So the one tail problem, this is one tail. You need to calculate what is T star. We can calculate T value. This is okay. Okay. And the survey is, we calculate the average X bar. 82.5. Okay. Sample standard deviation we can calculate. Let's do some sample standard 59.5. But my question is how to get this number? Normal T distribution table, and then we need to look at 12. So degree of freedom is n-1 is, it will be 11. 11 and 0.05. And then look at the T distribution table. 11. One tail. 5. 1.796. Okay, we calculate this one. We get this one from table. We calculate it, and this compared. It means T distribution like this is bigger than 1.796. Okay, this is critical value. It's T star. But our calculated T is here. 0.902, the inside. So this is accepted area. Okay, so fail to reject H0. That's correct. But problem is, what is p-value? P-value is, we need to calculate. I will use different color. We need to calculate this one. Highlight this. All this yellow area. Okay, 0.902, 0.092, 0.092, 0.092, and look at normal here. Point. Is that correct? I forgot that. Here we need to look at the what is percentage is outside here. When is 0? My memory is correct. 902, correct. 902. 902 is here. How to we calculate this area? It's very difficult. Okay. Here, 0.9. So we need some more data is needed. So in this case, it's better to use Excel. Okay, Excel will calculate for us. Let's try to solve this problem in Excel. Okay. The problem is 19. I quickly solve this problem using Excel. Here, 51, 175. Third one is 47. Third one is 49. And 44. 54. 145. 203, 21, 59, 42, 100. I do not know whether I missed anything, and then when you enter this one, press Control button and drag down and automatically, okay, all 12 numbers entered. Okay, I got here. PTO, I'm 175, 47, 49, 44, 54, 145, 203, 21, 59, 42, 100. This is data, what I need. This is, I need data, okay? Using this one data, mega start, and means hypothesis test, and data, yes. This is yellow area, I select. Hypothesis, I didn't enter, I will enter directly the number. You can enter directly the number. How is it? 67, right? Is greater than 67. Teenagers 67 text messenger. At the 0.5 level, can you conclude that mean number is greater than 67? So it is alternative is greater than. This t-test, and alpha is 0.04. So 95 is correct. Click OK. So I will copy this one. Copy. And I will touch here. So t-value. T-value. We have calculated, okay? T-value, I'll calculate 0.902. 902, 903 is a truncation. Okay, when the real number is like this, but p-value is automatically calculated. This is much easier for us to conclude. This p-value is greater than alpha. Alpha was 0.05. P-value is greater than. Okay, so is like this. T-value. Alpha is T star. We do not calculate T star. When T star is here, it will be alpha. But T is calculated. This is P-value. This is P-value. P-value bigger than, so this is less than T star. So in conclude is H0 will be accepted. H0 will be accepted. Fail to reject means accept. You will accept H0. And conclusion is mean number of text messenger is not greater than 67. Same thing. 62 hour is 82.5, right? Average. I will calculate. I didn't calculate 82.5. So let's, what is the average here? Like 82.5. 82.5 and 67 looks quite different, but problem standard deviation very wide. See, some students a lot, some students very low, you know, because of very big standard deviation. These two, we cannot say 82 is bigger than 67. It's almost same, no difference. Okay, so we fail to reject. Conclusion is like this. So we calculate p-value. P-value, I have calculated p-value directly. Yeah, 19. If you calculate the table, you need more detailed t-table is needed, or you can use Excel function Excel, you see, you can use Excel, Megastart option programs. Next is 23. Textbook. The management case small industries is considering a new method of assembling a computer. The current assembling method is required mean time is 60. This current method 60 minutes with a standard deviation 2.7. Sigma is known. Using the new method is the mean absolute random select 24 was 58. You see, 60 reduced by 2 minutes, but alpha is 0.1. Can you conclude that new assembling is faster? The type 2 error will be calculated. Okay, so you see 58. So I will draw like that. Yes, 60. 2.7. So at 90.1 is n is so it's better to use jet value because sigma is known. Okay, 0.1 is 1.282. So I will use normal distribution table. This normal distribution 0.1. So it means alpha is 0.1. This is 0.05. This will be 0.45. 0.45, we need to look at 0.45 is here. 1.645. It's 1.645. You need to 1.645. Huh? 1.2? So it's one tail problem. Sorry, this is one tail problem. So one tail problem is we need to calculate 0.1, one tail. It should be 0.1. Then it will be 0.4. 0.4, where is it? Between here. 1.2, is it correct? Between 8 and 9. 1.28 something. We calculated 1.282. Okay, less than the previous one is 60 minutes, 58. 60, 58 is here. So we calculate the that value is, we will calculate like this. Okay, 60, 1 point minus 1.282 plus 1.282 is, this is corresponding x value is 5982. How to calculate? You need to calculate backward. Z equal to x minus mu divided by n. Then Z was minus 1.282 equal to x minus mu is 60 divided by sigma 2.7 divided by square root 24. And then you can solve this x value. X value is 159.82. Okay, 59. Sorry, 59. 29. This is just critical. Okay, so if it is outside, it's greater than, it is a one-side problem or one-tail problem. So it's less than is H0, H1 is correct. In this case, H0 is accepted, and so on. When you calculate, J value is very low, so we will reject. The same assembly time is less than 60. Type 2 error, the question is, this is more critical. How to calculate type 2 error. Then, when you look at, I will erase something. $60 is Z0 and Z value is minus 1.282. Then corresponding X value 92.29. Okay, this is rejection. This is accept. Actually, this problem is, read carefully, 24, average 59. So actually, this problem is 58 is here. This is distributed like this. Then we need to look at this number, blah, blah. If it is here, it will be accepted area. So it will be type 2 error better. So it's 59. So this is 59, 29. Using this one, we need to calculate what the value is 59.28 divided by minus 58. Sigma is 2.7 divided by square root 24. We calculate Z value again. Okay, Z value we calculated using this one is 2.34. We calculate 92.29. Z value will, but this is different. The previous one is here mu was 60, but here is 58. The value is now is different. So we want to know bigger than 2.34. This is very important. 2.34. So this is 0.0096. I need to get 2.34. 2.34. I need normal distributed table. This is T 2.34. Okay. I need this one 2.34. Oops. $2.34. This is better. So we need to find out. The zero is here. 2.34. 2.3. 1, 1, 2, 3, 4. This area is 0.4904. Then this area beta is 0.5 minus 0.4904. This 0.0096. I've calculated this one. 0096. This chapter 10 is very important. Next chapter is 2 samples. We will compare first sample, the second sample will be compared. Okay, so I will, these 5 questions, your homework due is next week. Okay, submit your solutions to classroom. Okay, and chapter 10, one sample. Using one sample size of n, and then we will test h0 mu is some number, or alternative is mu is not, for example, 100. It is two-tail problem, or one-tail problem is mu is less than equal to 100. Alternative is mu is greater than 100, something like that. Okay, but whatever do that, we have two things. Sigma is known, or sigma is unknown. When sigma is unknown, we will use t-test. Is known, we will use z-test. And z will be compared to z star. The t will be compared to t star at alpha. When alpha is given, one tail, two tail, z value, t value, t star will be different. Instead of this one, we will, much easier one is, we will calculate p value. P value is relating z star or t star. Okay, so this is relating to p value. ZT, no. I'm wrong. Critical value is relating to alpha, and this is we test the statistic. We calculate p value. P value is corresponding to z or t, test the statistic value. Critical value is corresponding to level of significance. So we will compare directly like this. It's much easier. By computer, p value is easier to calculate. But when you use normal table, normal distribution table or t distribution table, this is much easier. When you use a table, in table and then you read backward, you can calculate p-value. But with a computer program, you can calculate p-value directly, so it will be easier for you. Okay, that's chapter 10. Chapter 11 is different. Chapter 11, two samples. Two group 1, group 2. Here, x1 to the blah blah xn. This is I will say 1 1 and 1 n. This is x21, second sample 2 2, and x2 m. And then we will calculate average of first sample, average second sample, and then we will compare. This is a sample of population 1. It represents population 2. For example, this is man, this is woman. Okay, so it is population. Man's average mu1, ladies average mu2. Is it equal or is not equal? Two groups population mean will be estimated using two samples standard average and standard deviation. Or if this two-tail problem, in one-tail problem is mu1 is less than mu2. The mu1 is greater than mu2. For example, this will be H0. This is alternative proof. This is then it will be wanted problem. Sometimes paired means here one first group, second group, sample size is the first one size n, the second one is m. N and m is not necessary to be same. But sometimes two sample size must be same because individual data is matching each other. One-to-one the matches, then it will call paired comparison. Next week, next chapter 11 is when we have two groups, and we will be compared. Okay, today is we will discuss about only one sample, and to check standard sample mean. Using sample mean, we will try to estimate population mean is equal to some number or greater than or less than some numbers and so on. So such hypothesis is tested from random samples analysis. Okay, I hope everybody understand chapter 10. If you do not understand chapter 10, chapter 11 will be more difficult and so on. Okay, try to solve these 5 questions and submit your answers to next week. Okay, any questions for the chapter 10? No question?
No, Professor.
Okay, if you have any question, you can send email. Do not hesitate. Or if you have a question about exercise, homework problem, you need to let me know. Okay. For example, this exercise, you can get this photocopy from library, or I will take photo and I will upload these questions. Okay, in classroom. I will, right after dinner, I will try to copy of this one and I will upload. Is it okay?
Yes,
Okay.
No. Okay. Then let's call it a day. Let's see you next week.
Goodbye,
Goodbye,
Professor.
Professor.
Goodbye, sir.
Goodbye, sir.
Bye-bye.
Bye, sir.
Yeah, bye-bye.